From twinkling stars to mysterious radio bursts, space holds secrets in its quantum dance. Today, we'll explore how stars might be nature's ultimate communication network, sending messages across the cosmos through quantum mechanics and light. Let's dive into one of the weirdest parts of quantum physics: entanglement. Imagine two particles that are connected in such a special way that whatever happens to one instantly affects the other, no matter how far apart they are. Einstein called this spooky action at a distance because it seemed impossible. When two particles become entangled, they're like cosmic dance partners. If one spins left, the other instantly spins right. Scientists have actually tested this with light particles from stars that are light years apart. The really cool part is that this quantum connection happens faster than the speed of light, which makes us wonder if nature has found a way to send information across space that we're just beginning to understand. This might be happening all around us in the stars, creating a vast network of quantum connections throughout the universe. Let's turn our attention to neutron stars, those amazing cosmic lighthouses that send out regular pulses of energy into space. These stars spin incredibly fast, sometimes hundreds of times per second, shooting beams of radiation from their poles like a cosmic lighthouse. When these beams sweep past Earth, our telescopes pick up regular pulses of radio waves, almost like a natural Morse code from space. These signals are so precise that astronomers can use them as cosmic clocks. Some neutron stars, called magnetars, have the strongest magnetic fields we've ever found in the universe. They're so powerful that they could erase a credit card's magnetic strip from halfway to the moon. These stellar beacons might be more than just spinning stars. They could be part of space's natural communication system. Let's explore how starlight might carry quantum information across space. When stars emit light, they're not just sending out simple waves of energy. Each photon could be carrying quantum data. Think of it like a cosmic version of fiber optic cables, but on an enormous scale. Scientists have discovered that photons from stars can remain in special quantum states even after traveling for thousands of light years. This means starlight might be nature's own internet, carrying vast amounts of information we're just learning to read. The light reaching us from distant stars could contain encoded messages about the quantum state of matter at their source. Researchers are now developing new ways to capture and study these quantum properties in starlight, hoping to unlock this natural cosmic network. It's like the stars have been running their own quantum internet all along, and we're finally starting to tap into it. Now let's talk about one of space's biggest mysteries: fast radio bursts, or FRBs. These are super bright flashes of radio waves that last for just a fraction of a second, but pack as much energy as the sun produces in decades. Scientists first spotted these cosmic flashes in 2007, and they've been scratching their heads ever since. While most FRBs are one-time events, some actually repeat in patterns that seem almost too organized to be natural. This has led some researchers to wonder, could these be signals from advanced alien civilizations? The truth is probably less dramatic. Many scientists think these bursts come from supermagnetic neutron stars or other extreme cosmic events. But the regular patterns in some FRBs keep that tiny possibility of alien communication alive in our imaginations. Let's peek inside the amazing tools scientists use to study these cosmic quantum signals. Modern observatories combine huge radio telescopes, super-sensitive light detectors, and powerful computers to catch and analyze signals from space. These machines can detect single particles of light from stars millions of light years away. Special instruments called quantum receivers can measure the delicate quantum properties of starlight without destroying them. Scientists also use something called coincidence counting. It's like catching two cosmic dancers in the act by measuring pairs of entangled particles arriving from space. The really exciting part is that these tools are getting better every year. New telescopes can now spot patterns that were invisible just a decade ago, and quantum computers are helping us process this cosmic data in completely new ways. Stars aren't just silent balls of light, they're actually humming with sound waves that bounce around inside them. These vibrations make stars expand and shrink slightly, like a giant cosmic drum. Each star has its own unique pattern of vibrations that tells us about its size, age, and what's happening deep inside. Our Sun, for example, moves up and down by just a few miles every 5 minutes. Tiny movements for something so huge. Scientists can hear these star songs using special telescopes that measure changes in the star's brightness and color. It's like each star is playing its own music in space. By studying these stellar songs, we've learned amazing things about stars' inner structure and how they change over time. This technique, called asteroseismology, is like giving stars a medical checkup from millions of miles away. Here's where things get really interesting. Scientists are using starlight to create the most secure codes ever made. When light travels from distant stars, its particles maintain special quantum properties that we can use for encryption. Think of it like having a lock that can only be opened with a key that nature itself creates. By measuring these quantum properties in starlight, we can generate totally random numbers that are perfect for creating unbreakable codes. The best part? If anyone tries to intercept these stellar messages, the very act of spying would change the quantum properties and reveal the eavesdropper. Several research teams have already used light from stars hundreds of light years away to encrypt messages. It's like the universe is helping us keep our secrets safe. Let's explore how binary stars might be showing us the perfect way to share information across space. These stellar pairs dance around each other in precise patterns, sending out regular changes in light and gravity that we can measure from Earth. When binary stars orbit each other, they create predictable patterns in their brightness. Sometimes one star blocks the other, causing the light to dim and brighten like a cosmic Morse code. These light patterns are so reliable that astronomers can use them to measure distances in space and understand how stars evolve. Some binary pairs even exchange matter, creating brilliant displays of energy that we can detect across thousands of light years. It's like watching a natural broadcast system at work. Here's a mind-bending idea. Stars might actually be nature's hard drives. Scientists are exploring how the quantum properties of stellar matter could store and preserve information. Just like your computer's memory chip, the atoms inside stars maintain specific patterns that could hold data. The superhot plasma in stars creates perfect conditions for quantum states to last a long time. Think of it like a cosmic USB drive, but instead of electronic circuits, it uses the natural behavior of atoms and light. Some researchers suggest that stars could be keeping records of everything that's happened in their neighborhood of space. The really amazing part is that this information might be shared between stars through their light and magnetic fields, creating a vast network of stellar memory banks. Let's look ahead to an amazing possibility, using stars to build a huge space internet. Scientists are working on ways to use starlight and quantum physics to send messages across huge distances in space. The idea is pretty cool. We could use the quantum properties of starlight as natural communication channels. Imagine setting up special receivers near different stars that could catch and decode quantum signals. These signals would be super secure because they use nature's own encryption system. We're already testing some of these ideas here on Earth using satellites for quantum communication. The next big step would be extending this network deeper into space, creating a web of quantum connections between the stars. This could revolutionize how we communicate across the cosmos. Thanks for joining me on this journey through the cosmic quantum network. There's so much more to explore in our amazing universe. If you enjoyed learning about space's hidden messages, hit like, subscribe, and share with a fellow space enthusiast.